Alrighty, so today we're going to have a look at polynomials, and in particular we're going to be looking at power polynomials. So let's have a look at them. So you can see here I've just created two sliders. At the moment I'm going to leave a as 1, but what's the more interesting thing is I want to look at what happens to n. And I only want to look at steps of 1. And in fact I don't want to look at anything. Let's look at like this. Alrighty, and so now I can just drag it around and we can see what the different shapes are. So if a is equal to 1, then we're looking at y equals x to the power of n, and if n is equal to 1, then it's y equals x, and this would be y equals x squared, x to the 3, x to the 4, x to the 5, 6, 7, 8, 9, and 10. And so we can kind of get the idea of these different shapes that we can see. So what we'll notice, if we go up in lots of 2, is that if we're only looking at the odd ones, so this is a linear function, a cubic, a quintic, a septic, and a nontic, that they're always increasing functions, basically meaning at the lower end, it's going upwards, and it doesn't matter which of the functions we look at, doesn't matter which of the functions we look at, we get that same pattern either way. Whereas with the even functions, you can see that we always stay positive, right? If I was going to make a little picture on it, right, you can see that it's always pointing up on either side. So this tells us a fair bit about the domains and ranges of these functions. For any of these even functions, well, the domain, well, that's just going to be x is inside double R, so there's no restrictions there. Whereas for the range, it's going to be from 0 up to infinity in this particular case. Whereas that's not the case for the other one. For the odd functions, both the domain and the range are going to be double R, because all numbers are possible in both directions. Doesn't matter what R value you choose, n value you choose, you're going to get that. What happens when I change a though? Well, let's have a look at a cubic. As I increase a, it is dilating in the vertical direction until I get to negatives. And as soon as I get to negatives, instead of becoming an increasing function, pointing up to the top right, instead it becomes a decreasing function when a becomes negative. As you can see, it goes from high to low now. So it's pointing downwards. And that's true for all of these functions. It doesn't matter which odd function I choose, we're always going to be looking at that case. So now that we've kind of got a bit of a feeling for these functions, let's have a look at the even ones as I change it. If I go back and change these so that it's only even functions, you can see is that when it's negative now, that they're all just concave down instead of concave up. So that's all it changes. So let's take some notes. Alrighty, so let's have a think about what the different things we can take away from this. So let's split it down into n odd and n even. So n odd shapes are always either going to be like this or like this. Whereas for n even, they're either going to look like this or they're going to look like this. Obviously the straight line's a little bit different. It looks like this and like this, but that's actually not that dissimilar to the cubic or the quintic. Looks quite similar, just they're obviously a little bit more curved. So when a is bigger than 0, then it is going to be what we call an increasing function. And another way of explaining an increasing function is that as x goes to infinity, y also goes to infinity. Whereas when a is less than 0, we get a decreasing function. Meaning, when x goes to infinity, y doesn't go to infinity, it goes to negative infinity. Alrighty. Now, it's a little bit different for these other ones. However, I only spoke about as x goes to infinity. So let's also talk about what happens when x goes to negative infinity, because it's different for these two functions. Alrighty, so then as x goes to negative infinity, well, y is going to go to negative infinity, right? Because it starts low, ends high when a is positive. When a is negative, though, it's reversed. As x goes to negative infinity, y goes to infinity. Starts high, ends low. Alrighty, let's talk about the same things, but for the even function. So if a is positive, then it is concave up, which means that as x goes to infinity, y goes to infinity, but also as x goes to negative infinity, y still goes to infinity, because it's up, up, doesn't change. Whereas when a is less than 0, we get concave down, which is the reverse. As x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y still goes to negative infinity, because they agree. Alright, so let's have a go at sketching these three functions. We've got 3x, negative 2x squared, and negative 4x to the 3. So for the first one, it's a linear equation. It's got a positive a value, which means it's going to look something like this. So, as x goes to infinity, what happens to y? Well, y also goes to infinity. While x goes to negative infinity, what happens to y? Y also goes to negative infinity. It agrees. Alright, it goes through the origin because it hasn't been translated yet. We'll be looking at translating them in a moment. But let's also, while we're here, let's think about the domain and the range. Well, the domain and range, the domain is going to be x is in double R, and for the range, once again, we're also going to get y is in double R. Alright, let's look at negative 2x squared. Now we've been doing quadratics for a little bit of time, so we shouldn't be having too much troubles with this. It's going to be concave down, which means that as x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y also goes to negative infinity. And in this particular case, the domain, as with all of these, will be x is in double R. But the range is where it gets interesting, because the range here, the highest value, well, is going to be 0, and the lowest value is negative infinity, and so that becomes our domain and range. Alrighty, and the last one is going to be y is equal to negative 4x to the 3. Now, we know this is going to be the traditional shape, but because the cubic shape, but because it's negative out the front, it means that it's going to be decreasing, which means that as x goes to infinity, y goes to negative infinity, and while x goes to negative infinity, y goes to infinity. And once again, same as the linear equation, the domain and range are both going to be in double R. So there's a little bit of looking at sketching these functions. See you in the next one. Goodbye.